Hi, I'm Bob. Welcome back to the solutions to the exercises for the last part of Chapter 5, Consumer Welfare and Policy Analysis. We have used the budget constraint-indifference curves diagram to analyze the consumer's leisure-labor choice in the past several videos. And we have learned how to derive the labor supply curve from people's optimal bundles when the wage rate changes. We will continue today for the last 6 problems. Let's solve exercise 4.13. Suppose that Joe's wage varies with the hours he works. Wage is a function of work hours. Use both a graph and calculus to show how the number of hours he chooses to work depends on his tastes. We can draw the budget constraint-indifference curve diagram for the consumer's labor-leisure choice. There could be an interior solution or a corner solution. It depends on the slope of the indifference curve and the slope of the budget constraint. Joe's income equals wage times work hours. Since wage is a function of work hours, we have y equals a times h squared equals a times 24 minus leisure n squared. This is the budget constraint. Its slope is partial y over partial n, which is a function of leisure n. As leisure increases, the size of the slope becomes smaller and smaller. The budget constraint is convex to the origin. Suppose his indifference curve is also the usual shaped convex to the origin. The tangency condition for an interior solution is the marginal rate of substitution equals the marginal rate of transformation. Next, let's consider the condition under which we have the corner solutions. The slope of the intercept of the budget line L1 on the y-axis is minus 48 times a. We compare the slope of the indifference curves with it. If Joe likes goods much more than leisure, the marginal rate of substitution of the entire indifference curve may be smaller than 48 times a in size. The indifference curves are flatter than the budget line at that point. The corner solution occurs where the budget curve touches the indifference curve at E2. If Joe likes leisure much more than goods, his indifference curve could be much steeper than the budget constraint. The corner solution E3 is on the horizontal axis. He doesn't work. Let's jump to exercise 4.14. Derive Sarah's labor supply function, given that she has a quasi-linear utility function and her income is y equals w times h. What is the slope of her labor supply curve with respect to a change in the wage? We use the Lagrangian method to solve for the optimal choice, subject to budget and time constraints. The first two first-order conditions give the optimal level of y. Substituting it into the third condition or the budget constraint gives the solution for leisure. The work hours H equals 24 minus leisure. It is equal to W divided by 16. This is the labor supply function. To ensure an interior solution, the wage W must be within a range. The slope of the labor supply curve is 1 over 16. Let's find answer to exercise 4.15. Joe won $365,000 a year for life in the state lottery. Use a labor-leisure choice analysis to answer the following question. In part 1, show how Joe's lottery winnings affect the position of his budget line. The lottery winnings shift his budget line upward from L1 to L2. In part B, Joe's utility function for goods per day and hours of leisure per day is as follows. After winning the lottery, does Joe continue to work the same number of hours each day? What is the income effect of Joe's lottery gains on the amount of goods he buys per day? We can use the Lagrangian method to find the optimal choice of leisure and work hours. The first two first-order conditions give the solution for leisure. Plugging it into the budget constraint gives the solution for the optimal amount of goods. We find that his leisure consumption is independent of income. So the lottery winning does not affect his leisure or work hours. After the lottery winnings, the optimal amount of goods purchased is increased by the amount of lottery. That is, he increases his goods purchased by $365,000 per year or $1,000 per day. So the amount of goods he buys per day increases by 1,000, given that the price is $1. Let's go to exercise 4.16. We draw the figure in solved problem 5.5 to show that the consumer might not choose to work at the higher wage. The higher wage rotates the budget line from L1 to L2. If the slope of the indifference curve I at point E1 is larger than the slope of L2 in size, then he maximizes his utility in a corner solution, where his indifference curve I touches his budget constraint L2 at E1, where he does not work. Let's solve exercise 4.17. In solved problem 5.5, suppose that his parents will not give him Y star if he drops out of high school to work. Use two figures to show that he might or might not choose to start working when the wage increases. The budget line L shifts downwards compared to that in solved problem 5.5. He does not work if the corner solution E1 is on a higher indifference curve than the interior solution E2. If the opposite occurs, he chooses to work H star hours. Let's jump to exercise 4.18. The government collects a specific tax of T for each hour worked. Thus, a worker whose wage is W keeps W minus T after taxes and supplies H hours of work. The government wants to know if its tax revenue will increase or decrease if it lowers T. So that how the tax revenue changes depends on the elasticity of the supply of labor, eta. The tax revenue, capital T, equals T times H, where hours of work H is a function of the wage after tax, W tilde. We use calculus to find the answer. Partial tax revenue over partial specific tax rate can be written as two terms using the chain rule. We can arrange terms to form the elasticity of the supply of labor. Finally, we find that if the elasticity of labor supply is smaller than the wage after tax over the tax rate, the tax revenue decreases as the government lowers the tax rate. If the wage elasticity of the labor supply is greater than that value, the tax revenue increases as the government lowers the tax rate. The tax revenue and the tax rate move in opposite directions. Thank you for watching this video and subscribing to my YouTube channel. See you next time.